So reference angle, they are acute angles, okay? And acute angles mean angles between 0 and 90 degrees. So reference angles, they are always positive angles between 0 and 90 degrees. If we're doing this in radians, that means between 0 radians and pi over 2. This is degrees, and this is radian. Now, by definition, reference angles are the angles formed between the terminal side of the angle with the horizontal axis. An example, so part A. So assuming that we have the angle, let's say 120 degrees, which is in the second quadrant. The terminal side is going to be somewhere in the second quadrant. And the angle that I'm referring to right now is the angle of 120 degrees. So the reference angle, which we usually just put the prime on top of whatever the letters represent the angle. So if I'm calling the angle 120 as alpha, then alpha prime is the reference angle. And the reference angle is the amount between the terminal side of 120 degrees with the horizontal x. And because it has to be positive angle between 0 and 90 degrees, I'm of course referring to this side of the measurement here. So alpha prime is this much, right? It cannot be the other way, because the other way from between horizontal x and the terminal side, we already know is 120, so it cannot be the reference angle because it's more than 90 degrees. To usually do this computation, once you know where is the terminal side, you think what is the closest of the terminal side to the horizontal x, and that measure allows you to do the computation. So for example, I know that if I run from the beginning to here, I have 180 degrees. So if I take my 180 degrees, which is a flat angle, and subtract the 120 degrees, I will be left with that alpha prime quantity that I'm looking for right here. So 180 minus 120, so that is 60 degrees. So notice that 6 degrees is an acute angle between 0 and 90 degrees, and that's what we always expect to have as a reference angle. Now, why do we need the reference angles? Because as the name says, they're going to give us a reference for computational trigonometric functions, meaning they have the same values for the trigonometric function up to the plus and minus sign. For example, if I want to compute sine of 120 degrees using the reference angle, I want to find out what is the sine of 120 degrees using the reference angle. Notice that because the terminal side of 120 degrees is in the second quadrant, and sine is by definition y over r, meaning it depends on the y values of the point. So any point on the terminal side will have a y value that is positive. So sine of 120 degrees, I know has to be positive, right? So meaning when I look at this in terms of not the original definition, but the reference angle, I know it's going to be positive sine of 60 degrees as well. Meaning the reference angle and the angle that I start with, they have the same sine value, except sometimes for the plus and minus. Sometimes it's going to be minus. It depends on the quadrant. Remember, the acute angles, they all have everything positive. All this, the values will be always positive. But as you move to other quadrants, that may change. So I put the plus here just to indicate that I always need to pay attention if I have a plus or minus of whatever is the trigonometric function of the reference angle. I always need to adjust. So this is basically me think of the adjustment, right? When it's positive, there is not much of reason to adjust because it stays positive. Sine of 60 is positive, so we'll stay positive. But for other trigonometric function that may switch, may be negative, and again, it always depends on the quadrant. So this is my first example. Let me give some other example, also in degrees. So consider this my other example. Let's think of cosine of 200 degrees. Okay, cosine of 200 degrees. So I want to write this using the reference angle. So first I think, where is the terminal side of 200 degrees? So alpha for me right now is 200 degrees. So a quick sketch, you know that from here to here you have 180, so it has to go beyond 180. So somewhere around here I have a sketch. So this is alpha of 200 degrees. Okay. Now, the reference angle is the measure between the terminal side you see there and the horizontal axis, the shortest measure, right? So meaning I'm not going to measure this in this direction because this is way bigger than 9 degrees. I'm actually measuring this distance right here, and that's going to be my alpha prime, my reference angle. So alpha prime is, notice that I have to come up with a result, a difference that give me the result as a positive value because acute angles are positive between 0 and 9 degrees. So this time, instead of doing 180 minus 200, that's going to give me a negative value. I take the biggest angle first, and that is my 200 degrees. So I take my 200 degrees and then subtract 180. Notice that the result is going to be positive, right? If you do the other way around, of course, it's a negative angle and cannot be the reference angle. So this is just 20 degrees. So the reference angle is 20 degrees. So I want to find actually the cosine. Now, cosine of 200 degrees, which is in the first quadrant, the angle of 20 degrees is actually in the first quadrant. Let's say somewhere around here. Okay, that is the 20 degrees. But as a reference angle, I need to adjust, right? Because if I think of cosine of 20 degrees, oops, I need more space there. So if I think about cosine of 20 degrees, that is going to be always a positive value because it's in the first quadrant, the x value, which is the definition of cosine, right? The definition of cosine is x over r. So basically it depends on what is the point on the terminal side, which is positive x values for the first quadrant. So I know cosine on the degree has to be positive. But when I think of the original angle, the one that I really want to evaluate, the cosine of 200, that's not going to be positive. So for the 200 degrees, the angle, whatever is the point on the terminal side, will have a negative x value. So x value has to be negative, meaning cosine will be negative for 200. So I adjust. So cosine of 200 degrees is actually negative cosine of 20. So again, 20 is my reference angle. So when I use the reference angle, it's always come up as a positive value, but the original angle itself, 200, has a negative cosine. So again, I adjust, right? So this is my adjustment depending on the terminal side location, which is basically, think about the points on that quadrant. Does it has an x positive or x negative? Because that's going to actually influence the result for the cosine of that angle. Yeah, so this is continue unit 3. Trigonometric function of any angles. So we're going to write cosine of 142. So write using reference angles. First step is to write the angle in its standard position. So 142 is going to fall in the second quadrant. Again, you don't need to be very precise with your sketch. Put somewhere approximately, doesn't need to be precise, but you know it's going to be in the second quadrant. So this is the sketch of alpha being 142. Now, what I really need here is to find what is the reference angle And again, because this is the second quadrant, the shortest distance between the terminal side and the horizontal x is taking 180 and subtract 142. So alpha prime, the reference angle, is 180 minus 142. So alpha prime, the reference angle, is 38 degrees. I know now what is the reference angle, but since I want to write cosine, 38 degrees, the reference angle, cosine is positive. It's always going to be positive for the reference angle, so cosine is positive. But 142 though, because the terminal side is in the second quadrant. So think of points in the second quadrant. So any point on the terminal side of that angle will have an x value that will be negative. So the x value is negative because cosine by definition is x over r. And remember, r is always a positive distance, right? So x is actually tells me if I'm going to have positive or negative cosine of the trigonometry, of the value of the angle. So x in the second quadrant is negative. Therefore, cosine of 142 is going to be negative. So my answer here is that cosine of 142 is negative the cosine of the reference angle of 38 degrees. So remember, I needed to make the adjustment. So the minus sign here is very important. Otherwise, it's not going to be the same. So the next one, I want to do D tangent. So tangent of 609 degrees. So we want to write the tangent of 609 degrees using a reference angle. So it's going to be plus minus tangent of an angle between 0 and 9 degrees. And again, first step is to know where is the terminal side of 609 degrees. I wanted the coterminal angle for this. Why? Because it's go beyond 360. So the coterminal angle of 609, you're gonna subtract 260. It's 249. So meaning 609 and 249 have the same terminal side. So by the way, I could write this like here. So if they have the same position for the terminal side, the tangent is exactly the same. So the tangent of 609 is the same as tangent of 249. Okay, so now let me sketch this because I know what's the coterminal, and then I'll show you what's the reference angle, which is not the same thing as coterminal angle. So 609 is the full 360 plus 249. So 249 is going to fall somewhere in the third quadrant, right? Because it's something, 249 is between 180 and 270. So let me write the quadrantal angle. So again, this is 0 degrees. This is 90 degrees here. This is 180. This is 270. So somewhere in the third quadrant is my 249. And that's basically giving me the terminal side also for 609. So that is my alpha of 609, which has the same terminal side as 249. So the 249 helped me actually to locate the terminal side because they have the same position for terminal side. If they have the same position for terminal side, they have the same trigonometric functions. So therefore, the tangent of 609 degrees is the same as 249. But again, the exercise actually asked me to rewrite this, not using the coterminal, but the reference angle. Because it is in the third quadrant, we see that the alpha prime has to be this quantity right here. So alpha prime has to be the 249, and because I'm not going to subtract from 609, I will get something bigger than 9 degrees. I take the 249 and subtract 180. So alpha prime is my 249. Notice that this is the coterminal. And I subtract from the coterminal 180. So alpha prime is 69 degrees. And that makes sense because it's a number between 0 and 90 degrees. I'm looking for an acute angle, and that's very, very important. So now that I know what is the reference angle, now I can write. So the tangent, okay, so now we know 69 is the reference angle. So for the tangent of 609, let's think about if it should be positive or negative. Do I need to adjust the sign? And remember, for the reference angle, the tangent will be positive because it's the first quadrant. Everything is positive in the first quadrant. But when I move to the other quadrants, I needed to analyze what's happening to the points in those quadrants. So the tangent of the angle is always defined as y over x. So now it depends on both coordinates of the point. So the point is on the terminal side of the angle. So the terminal side of the angle is somewhere here. So if you think about any point in the third quadrant, right? So you have a negative value of x. So x will be a negative value. The y value also will be a negative value. So both coordinates are negative for any point in the third quadrant. Meaning if they both negative, when you do this division, you know you get a positive result, right? So the tangent in the third quadrant is positive because both coordinates are negative. So if you divide the negative numbers, you get a positive result. So meaning my tangent, finally I can conclude, and again, I can conclude what? That tangent 609 degrees has exactly the same value, positive, of tangent of 69 degrees. Okay, so that's the takeaway of all this analysis I did, is that tangent of 609 is exactly the same, positive, tangent of 69 degrees. And by the way, I can also write for the coterminal. So I know the coterminal has the same terminal position for the angle. So tangent of the coterminal, which is 249, is also tangent of 69 degrees. This is not what is asking the answer, but we can take away the same analysis for the coterminal. And for letter E, we have to do sine of 7 pi over 12. So again, this time you're dealing with radians. Obviously, I think the second class I showed you how to sketch without converting. Sometimes it's faster if you just convert to degrees so you know where's the terminal side. Again, that's the only reason why you want to know how many degrees this is equal. Not that we need for the computations, we just need to know the terminal side. So first, let me think what is 7 pi over 12. This is radians, so I want to convert this to degrees. So I'm going to do times 180 degrees over pi. So obviously I can cancel pi. So if I'm trying to simplify. So if I divide this by 6, I get 30. This by 6 is 2. 30 divided by 2, I get 15. So the answer is 7 times 15 degrees. So this is the same as 105 degrees. Now, why I want to know it's 105, at least in your head you do that. You don't need to write that conversion, right? This is not part of the problem. I just need to write sine of 7 pi over 12 using the angle of reference, which also should be in radians, not in degrees. So meaning the terminal side is going to be in the second quadrant. So this is in the second quadrant. So somewhere in the second quadrant, I have the terminal side of 7 pi over 12. I need this measure here. So if this is alpha for me, right, my angle, alpha prime is going to be 180, which is pi in radians. So in radians, this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. My reference angle, alpha prime, is 180, but again, everything is radian now, so I use pi instead, minus the given angle, which is this guy right here, 7 pi over 12. So this computation will give me the measure of the angle in radians, and that's going to be something between 0 and 90 degrees automatically, between 0 radians and pi over 2. So I need to do the subtraction. Remember, pi has a denominator 1, but to do the subtraction of fractions, you need the same denominator. LCD is 12, so multiply top and bottom of your fraction by 12. So that becomes, keep the denominator of 12, and then you have 12 minus 7 pi. So that's 5 pi. So alpha prime is 5 pi over 12. That's something between 0 and 90 degrees. You can see that this is less than a half. That is 0.411. Why I'm saying less than a half? Because it has to be between 0 and pi over 2. So pi over 2 is like having half times pi. And if you look at the two numbers in front, you can see that this is approximately 0.4166667. So that's why I'm saying it's less than a half, because a half means 0.5. So we're good. So that's definitely a reference angle. Now that I know the reference angle, let me look if sine should be positive or negative, right? We're talking about 7 pi over 12, the original angle, has a terminal side in the second quadrant. And sine, which is y over r, depends on the y value of the points. And for the second quadrant, the points have positive y value. So sine of 7 pi over 12 has to be positive. So we can now conclude that sine of 7 pi over 12 is equals to exactly positive sine of the reference angle of 5 pi over 12. So letter F of the same exercise in the textbook, that is cotangent of 13 pi over 9. So you're going to write this using the reference angle. So the idea is still the same. See where is the terminal side of 13 pi over 9. So you can do a quick conversion to see how many degrees, so you know what is the terminal side. Once you know the terminal side, find the reference and then think if it should be positive, negative of the reference angle trigonometric function. This is my conversion right here in the corner. So 13 pi over 9, we're going to multiply by 180 degrees divided by pi. So we cancel the pi's. Definitely I can divide 180 by 9, and that's 20. So 13 times 20 is 260. So 260 degrees is the same as 13 pi over 9. So why I need that? Not because I need to show that computation, but at least in my head I need to know where is the terminal side. Now 13 pi over 9 is gonna be in the third quadrant, right? Remember the quadrantals, which is 0, pi over 2, which is 90 degrees, 180, which is pi, and this is 270, right? So if this is 270, somewhere in the third quadrant is the location of the terminal side of 13 pi over 9. So again, draw somewhere there in the third quadrant. So you know that is your alpha of 13 pi over 9. And since now I know the location, obviously I need the reference angle. So the reference angle is this quantity right here. So again, I do alpha, but this time I do 13 pi over 9 minus 180, which is pi. Remember, 13 pi over 9 is bigger than 180. So when you do the difference, you need to come up with a positive result. That's why you do the bigger angle minus the smaller, which is the horizontal x, pi. Pi has denominator 1, so you're going to multiply top and bottom by 9, so you can do the subtraction. So keep the denominator of 9, and then do 13 pi minus 9 pi. That's actually what we need, and that's 4 pi. So 4 pi over 9. So the reference angle is 4 pi over 9 in radians. So we can now think about the cotangent. Remember, cotangent is the reciprocal of the tangent. So this is my scrap paper. So the cotangent of an angle is the reciprocal of the tangent. So if the tangent is y over x, this is x over y. So I needed to look at both x and y coordinates in the third quadrant to know if I'm going to have a positive or negative tangent. So again, x value in the third quadrant, they're all negative. So you have a negative number. And then y values are also negative, so you get a negative number. So meaning the cotangent in the third quadrant is positive, because if you divide two negative numbers, you get a positive value. Now I can write then the answer. So cotangent of 13 pi over 9, the original angle, is exactly the same positive cotangent of the reference angle of 4 pi over 9. Right? I put a plus there, but that's not needed. We know it's positive in any case. So this is the answer. Okay, so let's give you the idea how to work with reference angles to rewrite trigonometric functions based on that.